we are quite conversant with the very famous operating systems like iOS that runs on Apple devices. We are conversant with Android 7, 8, or 9 that runs on the Android phones. You're also conversant with Linux, like Ubuntu, Mint, and Debian. You should also be conversant with Windows operating system like Windows 7, Windows 8, and Windows 10. There might also be other that runs on servers like Windows Server 2012, Windows Server 2016. The last one that I used was 2012 and 2016. So these are the softwares that allow the computer to receive instructions from the user and pass on the instructions to the computer hardware. So they act like an interface between the application software. This is where you say application software and the computer hardware. So what you also observe is that there are a set of specialized programs that are used to manage all the resources and operations of a computer. So here, if we talk about resources, we're talking about RAM, we're talking about memory, we're talking about registers, we're talking about storage and the processor, among others. So those resources and their operations are managed by the operating system. Of course, they also do control and monitor the execution of the programs as they interact with the hardware. So what you see is that there's a user here. So a user might be wanting to interact with the Word or Microsoft Word or PowerPoint, among others. So what they will do is that they are going to be giving instruction to this application software. And then the operating system on which the application is running on will interpret those instructions. They are at a low-level language, and those instructions are then sent to the hardware, which now implements the instruction. So then this is the general architecture between the user and the hardware. You can see that the operating system plays a very pivotal role. Without it, you cannot communicate directly to the hardware. So it comes in as an interface between the software that the user is using and the hardware that requires to implement or to carry out the instruction. So there are some few objectives of the operating system, and one of them is that they make the computer system convenient to use and efficient manner. Without it, you would need to write instructions in low-level language, and I think I mentioned that in a past lecture. Low-level language is characterized by codes, mnemonic, pseudocodes. You would be giving in computer instruction not at a high-level language, but in the mnemonics. The mnemonics are the characteristic of low-level languages. They are normally very hard to even for the humans to understand. But high-level languages are in a form that is very easy for humans to understand. And therefore, we say that the application software are normally written in high-level language, and therefore it becomes easier. And therefore, when the user is interacting with applications like Word, you don't have to understand the programming language that the computer understands, only you are giving it instructions. So what you are saying is that it brings, or the operating systems brings some level of convenience and efficiency when you are operating a computer. The other objective of the operating system is to hide the details of the hardware resources from the users. Sometimes you don't want to know how much memory, how much RAM is being used by which application. Those details are hidden far away from the user. Therefore, the only aspect that the user is interested in is, can the computer do what I want it to do? Another objective is to provide users with a convenient interface to use the computer, and I think I have elaborated that point in this other point number 1. We also say that the operating system acts as an intermediary between the hardware and its users, making it easier for users to access and use other resources. And the OS manages the resources of the computer, and I think we have also said that it keeps track of who is using which resource, or granting requests to the person who request, or the application that requests, or the hardware that requests, etc. Sometimes you might be, I think the most recent conflict where I have seen where someone wants to use, they are using in a Zoom meeting, and they are showing their camera or their video camera, and then they want to use another application that wants to access the camera to show the video, and you actually realize that such a request is granted because one hardware can only be used by one application at a time. So that is the work of the operating system. And lastly, they also provide efficient and fair sharing of resources among users and among programs. So we discuss now some characteristics of operating system, and they are very much related to their objectives. One of them is memory management, whereby they keep track of the primary memory, what part of it is in use, what part is not in use, and which other program has requested it, and who should be given the priority to access a given portion of the memory. The other characteristic of OS is that they also manage the processor, that is allocating the processor to a process and allocating the processor once that process is no longer being run or has ended. Device management, I think I've also given that example. Device management is like that of a video camera, of a laptop. You are determining who has access to what device at what time and for how long. File management involves that you are allocating and deallocating the resources depending on which application has requested that resource. Security prevents unauthorized access to programs. You are, of course, very conversant with the simplest of the facts that you cannot use Microsoft Word unless you are logged in to the Windows. That is a very simple way in which operating system provides security to data and to programs. And then there are more complex scenarios which are probably for now beyond your level. And also the OS provides job accounting, that is keeping track of time and resources that are used by different programs and different users. The other characteristic of operating system is that they provide control over system performance. Sometimes probably you might see someone going to Task Manager and seeing which application is using which resource, and I think you might be conversant with this idea whereby we have a task manager. It shows you that the CPU is being used very much by a screen recorder. The memory is also being hugely used by the screen recorder. You can see this one is quite huge, and you can also see in my scenario, Firefox is using so much of my memory even in comparison to the screen recorder. So that kind of control is actually the one performed by the operating system. Therefore, we also say that the OS provides interaction with the operators. That is, you might find an operator that is giving instruction via console. That is mostly in terms of Linux. Console is the black command prompt that you normally use when you are giving instructions to operating systems like Linux, and that kind of interaction is provided for by the operating system. Of course, they also provides the detection of error. That is providing some traces of what problem occurred when. Sometimes you might be using a program like this one and then it hangs, and it has those kind of management of the errors that arises when you are using different applications is provided for by the operating system. And lastly, there is coordination between other software and users, that is assigning of compilers, interpreters, assemblers, and other software to the various users of the computer system. And these are the programs that normally interpret the instructions that are provided to a computer at high level, or the computer hardware that does the instructions in low level, and therefore that kind of coordination is again performed by the operating system.